Perfect. Thank you very much. So I know more than a handful of people in the room have seen earlier versions of this. This is joint work with Chris Nosko, who's sitting back there and will tell us some new stuff about Uber later today. And at the end, I'll try to inject some parallel follow-on work that I did with a couple of other colleagues at eBay that relates to this general agenda. And the general agenda is, oh, hold on, this needs to be in here. The general agenda is on the effectiveness of reputation systems in online marketplaces. So first let me start with something that everybody here in this room knows, and that is that platform markets or marketplaces are fundamentally different from retailers, primarily because what they do is they facilitate trade. They don't trade themselves. They are not sellers. So they really don't control some key variables such as inventory, what do we hold, prices, how do we ship, and so on and so forth, but rather rely on the sellers to do all that stuff. And naturally, because of that, you're going to have a variance in the quality of sellers who are on the marketplace. So, you know, whenever you buy something from Amazon, and if you buy it from Amazon as the seller, you know exactly what's going to happen, right? You're going to get it, if you're a Prime member, within 2 days. It's going to come in a box that's going to be well wrapped, and it's going to be exactly what you wanted. And with probability 0.01, shit's going to happen, and it's going to be easy because you're going to go online, you'll click 3 buttons, and you'll return it. Right? When you buy from a marketplace seller, in particular a place like eBay, there's going to be a lot more variance in what might happen. And this is where reputation and feedback comes in, because many have said, and I think the best quote comes from a paper that Chris Delarakos wrote about 12, 13 years ago, that really this reputation is what allowed these marketplaces to flourish. Without it, people would just worry too much about the asymmetric information, be it moral hazard or adverse selection. And we know that eBay introduced it. It's used by Taobao, Airbnb, Uber. Everybody uses some form of reputation. And in fact, you could even relate this to the more broad area of product reviews, in that, you know, Amazon or Yelp or TripAdvisor about the quality of products, not necessarily a particular seller. And more recently, I think a lot of platforms, and I think with some reasonable rationality behind it, have argued that really platforms are good self-regulatory mechanisms, because, you know, the platform wants quality to be good. You know, we don't need government to regulate this. The reputation system will take care of the regulation, and so on. But of course, for reputation systems to work, reputation measures should, first of all, accurately reflect quality, and buyers should correctly perceive this reputation to quality mapping. And really in this paper, we're going to take aim at both of these issues. We really can't do too much about the second thing, except from, you know, anecdotally talk about what seems to be out there, and you'll see what I mean. But we will be able to provide some pretty appealing evidence that reputations don't seem to accurately measure the quality of the transactions. So here's one way of describing the problem of reputation, right? This comes from a cartoon that Chris found, right? So 5 stars, it only has 1 review. 4.5 stars, excellent. 4 stars, okay, and everything else is crap. And I think this resonates with a lot of online platforms. So the question is, what's going on here, and how are we contributing to this problem? So because of the length of the talk, I'm going to skip a few you know, things in the introduction and dive into the paper. This will again a little bit follow what Chiara said. You know, this is kind of a more specific paper and not so much an overview of a series of different agendas. But you will see I'll talk about 2 papers and how they reflect to this general agenda. So first, I think we're highlighting issues that really are missing from traditional platform models. And what I mean by that, there's a large literature in economics on economic platforms, and that literature is 95 to 98% concerned with how do you price these. I have buyers, I have sellers, I have this network externality. If I want the platform to flourish, where do I put the prices in order to create this better network interaction? And by and large, there's no discussion of asymmetric information or what we will refer to as quality spillovers or reputational externalities across sellers, because the thing is that Chris and I believe is, if I'm a seller on eBay and you buy from me and you have a crappy experience, in your head, you're not saying, oh, eBay is awesome, you know, Steve.Tadelis123 is a horrible seller. In people's mind, it's going to be, I bought something on eBay and I was screwed and I'm not happy with eBay. And we're going to show some evidence that is indeed true. The second thing is we're going to highlight some issues that are missing from the traditional models of reputation. And here I'm as guilty as anyone else who's written in the field of the economics of reputation. This is work that I did in my dissertation, which is why this topic has always been near and dear to me. When you write down an economic model of reputation, typically it's going to be some repeated game or dynamic model of adverse selection where people do some kind of Bayes updating about history vis-a-vis the type of seller that they're buying from. Or if it's pure repeated games, it's just, kind of a folk theorem, bootstrap equilibrium. If you'll be good, I'll pay you, and as long as I pay you, you'll be good. And in those models, we assume that the reputation or the history is exogenously generated. Okay, so on one extreme you have the perfect information models, perfect recall models, where all the histories of the past are there for everyone to observe it. Every new participant in this game sees the histories and knows exactly how to do the inference. And of course, these are equilibrium models where people understand what they mean and they act accordingly, and everybody is best responding to their beliefs. In reality, reputation is not given out there either perfectly or even imperfectly with some noise. It is user-generated content. So we need to understand something about how these reputation measures are created in order to understand how to interpret them. And then, of course, the question is, are people correctly interpreting them, which is outside the scope of equilibrium analysis, and as an economist, that would be blasphemy to even consider that as an option. But I will at least show some respect to that possible idea. And furthermore, what this is going to do is going to cause these reputation systems to either be skewed or just completely uninformative. And the question then is, how could platforms deal with that? And what we're going to argue is that what marketplaces or platforms need to do is to augment the feedback system with their own ability to self-regulate. And we do believe that these platforms have the incentives to self-regulate because this ties in very nicely to some of the things that Susan said in her talk, in that you have the short run and the long term. And of course, for these platforms to survive, they really have to care about the long term. So it is in their interest to provide good experience to both sides of the market. And what we're going to argue is that these marketplaces can find information in their data that could augment and maybe even replace reputation systems more generally. And what we're going to do here, which is unlike a typical economics paper, we're not going to have some optimal solution like in a theory paper, but rather we're going to offer a proof of concept. And what we strongly believe, and I think I'm speaking for both Chris and me, and Chris will correct me if I'm wrong, at some level, this is a bit of an engineering problem. Okay, what works best for eBay may not be the best solution for Uber, may not be the best solution for Airbnb. This will be a function of the kind of data they collect, the kind of transactions they have, and so on. And you'll see what I mean by that. And last but not least, we're going to suggest this engineering implementation to go through the search mechanism. In other words, we know from a lot of the literature that computer scientists have done on search, and some economists, that the more prominently you're displayed. I mean, Susan mentioned this in one of the experiments they did when they switched the first and the third rank, and you saw the amount of traffic that drops. So that means that if I, as a platform, believe that certain sellers are lower quality, if I dump them further down the search, the likelihood that people will click on them is much lower. And in fact, you might even argue that, in some longer run, with better personalization, you might even be able to do this on a personalized level. So for example, if Ramesh is new to my site and he comes and then, I notice that he's a new buyer, I might want to give him the red carpet, silk gloves, awesome experience. and he's going to search for some query, I won't even show him sellers that I'm not that sure about. On the other hand, if Hal comes and he's an experienced eBay user, then I'm saying, you know what? I know that Hal knows how to read between the lines. I'm going to show him the back alleys of my marketplace. And he buys so much that if he's not going to get a good deal, he won't hold that against me, the eBay platform, because he knows so much about eBay, right? So we could even think of personalizing that. So let me give you this is going to be our theory slide. Okay, this is the conceptual framework that we're taking to the data on eBay. And that is, think of a buyer as a dynamic decision maker, some Bayesian dynamic decision maker that comes to eBay with some prior belief. I'm not sure how good eBay is. Let me try it out. I buy a product. I have an experience. I'm unhappy. I might decide I don't like eBay. I'm leaving. I'm never coming back. Or I'll buy a second time. I buy a second time, I'll get an experience, I'll update my belief, I might leave the platform, or I might buy again. So really you could think of any particular decision maker as a probability distribution over these terminal nodes. And basically we're looking at how will this person proceed dynamically, where of course the underlying truth of such an economic decision maker would be, the better my experience is at any given moment, the more likely it is that I will continue purchasing. And second, the further down I am along this tree, the less likely any given experience will matter. So, I'll have a pretty diffuse prior early on, but if I'm on transaction number 100 and I get screwed, you know what, I might say, hey, shit happens, I'll continue. Whereas if I get screwed on the first transaction, I may be a lot more likely to attribute that to the quality of the platform. Ilya.
Rule out the reputation system from the model where buyer observes something?
No, I'm not going to rule that out. This is going to be included in the model.
I also update based
maybe
I was an idiot I bought from the store reputation.
Yes, that's true. So again, from after this slide, everything is going to be empirical, but we will control for the reputation in the empirics. So we're very much allowing for that. And in fact, I'll show you something in one of the regressions that I think is going to be, initially counterintuitive, but then when you think about the issue of selection, it won't be regarding exactly selection on reputation. So the question is, what could buyers use, exactly as Ilya said, in terms of this reputation to form some initial expectation? So, I do this in every time I give one of these talks. How many people here have bought on eBay? Just out of curiosity. Okay, so this audience is more than average. I'm not going to ask you how many people buy on Amazon, because everybody should raise their hand. If you're not raising your hand, you either didn't listen to me or you're lying, right? So, and there's a good reason for that, but that's for lunch or beer. And so when you go to eBay, we know that buyers choose to leave feedback that could be positive, negative, neutral, or nothing. I could choose not to leave any feedback. This is what eBay does with that data. It offers two measures of reputation for the seller. One is the percent positive, which is the number of positives divided by positives plus negatives. And the second is the seller feedback score, which is the number of positives minus the number of negatives. So the more you sell, the more positives you get. The score is growing basically, unless you start just getting negative after negative, which, as we'll show you, is very unlikely. And this is just the percent. Another thing that eBay does with the reputation, they have their own standards. So for example, I'll show you a badge. A seller might get an internal eBay badge that says, this is a trusted seller. So this is a eBay Trusted Seller, ETRS badge, that eBay uses with this data and other data to, basically give people some kind of stamp of approval. So I'll show you an example of two sellers. So here's one seller. This seller's name is Samnas04. You see it over here. This seller has a reputation score of 317. So positive minus negative equals 317. And positive divided by positive plus negative is 96.9%. So, this is a group of extremely accomplished people. I know that in the U.S., quite a lot of people get a 4.0 GPA as undergrads who continue on to the kind of careers that people like you have. But anyone here who comes from outside the U.S. is very unlikely to have an undergrad GPA of 96.9. Okay, so in some absolute terminology, right, 96.9 is a very high number. Okay, Here's another seller. This seller, and this was for a MacBook, and you see that it's used. Here I have a MacBook that's new. This seller, Blue Tech USA, has a reputation score of 44,949, has 99.5% positive instead of 96.9. Again, is that a big difference? Well, that's a good question. This is a top-rated plus seller, so this seller has the eBay badge. And this is, what the buyer sees. Every time they will click on an item, they will see the reputation of the seller. So the question is, what's a good number? Well, this is the distribution of feedback on eBay, okay? 100%, the red is unweighted, the blue is weighted by transaction volume. So you see that there's a huge number. In fact, over 60% of unweighted sellers have 100% positive. By the way, I started this graph at 98%. Okay, so 96.9 is, like in the 5th percentile of the distribution. Okay, so this number that sounds pretty impressive is completely unimpressive. In fact, it's pretty poor when you think about eBay. The mean is 99.3, the 10th percentile is 97.8. So, of course, there are two ways to interpret this data. One might be that everything is working perfectly. Once a seller screws up a couple of times, nobody buys from them anymore, they die off, the platform gets rid of them, and they're gone. Okay? Alternatively, this is just, Lake Wobegon on steroids. Everybody is above average. Everybody is awesome. So here's a little bit of evidence. Oh, go ahead.
I thought a few years ago there was a redesign where there was more negative feedback because they went to this one-directional feedback.
Yes.
Is this that?
This is all post that. Okay, this is way post that. Yes. Yeah. It's still pretty bad. And that's a cool study. Yeah. What David mentioned is on eBay you used to be able to leave two-sided, and I'll actually get to this in a second because retaliation was one of the issues that came up with. So either this is nirvana or it's heavily biased, and here's some evidence that this is not nirvana. This is not this great site where the bad people get kicked out and so on. So as I mentioned earlier, positive feedback, an average of 99.3. Of the remaining 0.7, about 0.4 is negative feedback and 0.3 is neutral feedback. I'm going to jump to the third one, the fourth one, dispute filed. This is where an eBay buyer tried to resolve something with the seller, or at least most likely tried because you only could file a dispute after you try that, was unhappy and went through the process of filing a formal dispute with eBay. That is a non-trivial amount of work, okay? Whereas leaving a negative feedback is a trivial thing, click, send, end of story. So one kind of puzzling fact is, how come the propensity of filing a dispute is almost 3 times the propensity of leaving negative feedback? Well, we dug even deeper, and I'll mention this at the end, what we could do with this. Look at post-transaction emails. It turns out that almost 9% of transactions have an email sent by the buyer to the seller. It's actually an internal message after the transaction. Why would you want to send the seller? I mean, it could be that you're just saying, hey, this is awesome, thank you, I love you, right? Well, with a little bit of simple NLP, baby NLP, you could look for words like late, broken, where is it, disappointed, and so on. And you get that almost 10 times as many negative feedbacks, there are ex-post messages from buyers to sellers that say something didn't work for me. So the question is why? Well, here's one reason that might happen. So this is an article from a few years ago. eBay shopper says he was harassed by seller. Colorado State University student wants to return bike, gets recorded threats. The first message he saved on his voicemail, don't you play games with me, goddamn you, I'll follow you to your grave. He knew everything about me, said Black Welder, that's a student, my phone number, my address, my name, it's a little scary. So this is a student who bought, left negative feedback. The seller was very upset and started threatening him. There is an incident in the UK about 4 years ago, and one in the US 2 or 3 years ago that I saw, where sellers sued buyers who left them negative feedback for defamation. Okay, And this doesn't only happen on eBay. You know, here's a Yelp review, okay? So last week, a Fairfax, Virginia jury found that homeowner Jane Perez defamed her contractor when she wrote a pair of scathing reviews of his services, accusing him of botching her home, blah, 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 right? This kind of reminds you of the McDonald's coffee incidents for those who are old enough to remember that. You know, with all this crazy tort law. Well, of course, if you are a buyer and you read something like this, and then you buy some item on eBay, say for 15 bucks, and it's not exactly what you wanted, and you try with the seller and it doesn't get resolved, and you kind of think, should I leave a negative feedback? And you read something like this, and your most likely reaction is, excuse my French, fuck this, I'm leaving the site. Okay, I just don't want to deal with eBay anymore. And of course, what that would create is this hazard that people with negative experiences, even if they stay on eBay, they might not report them because they're worried about these things. And of course, they might just leave without reporting them, and then we're missing a lot of information. So if that's the case, if leaving feedback is a hassle, then that alone doesn't imply that it's biased. But if the cost of leaving feedback depends on the quality of the transaction, then it would be biased. So what do I have in mind here? You know, we are in Berkeley, and for those who are non-economists, Berkeley is kind of the haven of behavioral economics. So if you wanted to write some behavioral economic model that some people are, you know, they have social preferences, right? I like to provide a public good, because I'm sure you all know in economics, everybody's a selfish bastard, nobody does anything for society. But imagine if you have preferences, I want to help other people, you could think of some positive utility or negative costs that people have from leaving feedback, right? So that means that some people who are more social-minded leave feedback, others who are less social-minded don't leave feedback. If the only thing that determines whether or not you leave feedback is your benefit or cost of leaving feedback, but that doesn't depend on the quality of the transaction, then feedback won't be biased. Let's say only 50% of the people leave feedback, but it's still an unbiased estimator of the truth. However, the suggestive evidence of the hassle of you know, the lawsuits and so on means that if I have a positive experience, I'm okay leaving feedback. If I have a negative experience, my cost of leaving feedback is suddenly higher because of this retaliation. This brings the bias in, which then results in the obvious claim that leaving negative feedback is more costly, and because of all the reasons I told you, and that implies now that silence is a combination of two things. It's a combination of selfish bastards and unselfish people who would have left feedback if it were positive, but are not going to leave feedback if it's negative. And that, in turn, means that we could use the silence as a measure of negativity because there's information in the silence. And this goes to a nice paper by De La Rocas and Wood in 2005, where they conjecture that silence is a problem. And they propose a kind of two-sided reputation econometric model to try to reveal how much bias there is. But, you know, as David mentioned, eBay changed the reputation system in 2008. Now sellers cannot leave negative feedback on buyers anymore, so their econometric method just doesn't work. We have the benefit of, we were in eBay, we had access to the eBay data, so we actually could go and determine these things directly. So let me give you an idea of what we did here. So remember that percent positive, positive divided by positive plus negative. Silence was missing. Let's just create a new metric. We'll call it effective percent positive. And that's just going to be number of positives divided by number of transactions. So I'm taking silence, I'm throwing it into the denominator, and I'm therefore holding it against a seller. So here would be an example. Imagine seller A and seller B. Both have 99 positives and 1 negative. So if I ignore the silence, they would look exactly identical. They would both have a percent positive and 99%, 99 divided by 100. However, I'm going to assume that seller A, for example, has 120 transactions and seller B has 150 transactions. So now when I divide positive over total transactions, I get 82.5% EPP for seller A and 66% for seller B. And the claim is that seller A is a higher quality seller than seller B. Okay, that's what we're going to try to establish using our data. So first thing is to look at the distribution of EPP, and suddenly we get something that looks like a signal, right? You don't have that hockey stick of almost everybody has 100 and there's almost nothing below 98%. Here we have a nice distribution with some spread, but we're left with the question, is this really a measure of quality? So what are we going to do? What we did is we took a cohort of eBay buyers and we tracked them over about 3 years. So how do we do this? We took new users who joined eBay anytime in 2011. We took 10% of all new users. That gave us a sample of 935,000 buyers, so almost 1 million buyers. They had to sign up and purchase an item within 30 days of signing up. By the way, we replicated this analysis for starting years 2008, 2009, 2010. The results are almost quantitatively identical. So this is pretty robust in terms of the impact. Then what we did is for every such buyer, we tracked all their usage until May 31, 2014. So on average, we have about 3 years per person. For some people, a little more. For some people, a little less. And that gives us over 15 million transactions that these people purchased. The data that we have, of course, is going to include, this is the internal data, so it's price, quantity, item category, who the seller was, what kind of sale mechanism, auction or fixed price, and so on. Then, since we have all these 15 plus million transactions, each one of them we could identify with a seller. That gives us a total of 1.8 million sellers who sold these 15 million items to these almost 1 million buyers. And for each one of those, we have their information, which is their feedback score, their percent positive. And then what we do is, since eBay doesn't have that in their original data, for every seller at any transaction, we calculate their EPP. Okay, so we add that as another seller characteristic at that moment. And then we're going to apply this data to our conceptual framework. Namely, you're purchasing dynamically, and we're going to ask, how does EPP affect your behavior? So this is one of the advantages of this paper, again, because we just had access to the internal data. Typically, empirical papers that looked at eBay transactions and try to see the effect of reputation on prices or stuff like that, they use scraped data. And there's a lot of problems using scraped data in terms of endogeneity and so on and so forth. We are taking what economists call a revealed preference approach. I'm going to look at the behavior of people as a function of the EPP of the sellers that they interact with, and the important thing is to remember that EPP is not observable. So if you remember, when I went to a seller here, okay, EPP is not listed anywhere, so I can't use that to select who I want to buy from, and therefore the variation in EPP will be considered to be exogenous, and then I'm going to show you experimental results where it really is exogenous because we did a treatment control. So this is kind of a snapshot, if you will, of that distribution along that decision tree. So remember, some people buy one item, some people exit after 2 items. So we took that 3-year period, and all the people who only bought once, it's as if they were on that first branch of the tree and they decided they're not buying anymore. Some people bought twice. So as you could see over here, a big majority of people, well, not a majority of everyone, but 38% buy one item and never buy again on eBay, which is a very high number. The median is 2. The mean is about 16 purchases, and but we see it has a very long tail, right? So the max, for example, is 19,359. This is someone who registered and just for the next 3 years sat at the computer and just bought stuff. So that's what it seems like. I'm just going to quickly skip over this, but this is just a matrix that shows that there is indeed the scope for externalities, namely, if I'm a seller and I treat you poorly, that will affect your belief about someone else, because most people, the more they buy, the more sellers they buy from. So people are not coming to eBay. It's not like I go to eBay and I heard that Elia sells on eBay. I'm looking for Elia, and then once I'm there, I just buy from Elia. That doesn't seem to be what people are doing. So let me tell you how we're going to measure the effect of quality on exit rates, and how we're going to try to look at this issue of the externality, namely how you're affected by one seller about what your behavior is, not only towards that seller, but towards eBay as a whole. So as I said, we're using this revealed preference approach. So we are going to define a variable, which is, say, yijt and yit. So yijt is going to be 1 if buyer I bought transaction T from seller J and after that, return to seller J. We're typically going to use 180 days. We've done robustness if it's only 90 days or a whole year, and again, the results don't change very much. So this is really looking at how a current transaction affects my future purchase behavior on eBay. And YIT is just going to be the same thing, but instead of returning to the same seller, it's just returning to eBay as a whole.
There's no J in the notation?
Sorry?
There should be a J in that notation, right?
No, well, J appears over. So this is the probability that that person I, after transaction T, returns to eBay. And we will control for the seller J's EPP and a whole bunch of other seller characteristics. So J is included here, but the idea is here we're looking at the transaction and not the transaction and the seller. That's why we use this notation. Okay. Then BIT bar is just a vector of buyer characteristics. So for example, how many transactions they completed, which is a measure of how experienced they are, and you know, other seller characteristics, other buyer characteristics. We have a vector of seller characteristics, for example, the feedback score, the percent positive, and other characteristics that we could measure. D bar T is a vector of transaction characteristics, like is it an auction or a fixed price, what the price was, categories, and so on. And in a way, the difference between these two captures this idea of how much of it is towards the same seller, how much of it is towards eBay as a whole. So here are the results from these main regressions. This is the same seller regression. This is the eBay regression. And let me tell you what our key interest here is. So recall, the way I wrote it here, I just wrote it as a linear regression. But what we've really done is something a little more non-parametric. So we took the EPP and divided it into first quartile, second quartile, third, and fourth. And the first quartile is the excluded variable here, and here the other three quartiles. So the excluded one is like the crappiest EPP, right, who we believe are the lowest quality sellers, better, even better, and best. And what we see over here are the marginal probabilities of returning to eBay. So what you see is that a seller from the second quartile relative to the lowest quartile, you're 0.5% more likely to return to the same seller. You're almost 2% more likely to return to eBay. If you're in the third quartile relative to the first, returning to the same seller is about 2%, 2.1%, and almost 3% more likely to return to eBay. And if you're in the highest quartile, returning to the same seller is about 2% more likely and about 4% more likely to return to eBay. So this difference really shows you that when a seller treats a buyer well, the impact on eBay is larger than the impact on the seller himself, which shows that that externality is really present. The other thing this shows you is that EPP really is a revealed preference measure of quality. When I show people higher EPP sellers, they are more likely to return to the seller and to eBay. So this really is through the revealed preference capturing some measure of satisfaction, right? You know, if I always kind of felt that the right name for this paper would have been Exit, Voice and Loyalty in Online Markets, for those who are familiar with Hirschman's famous book on exit, voice, and loyalty, right? So here we're using exit, right? You're leaving eBay as a measure of dissatisfaction. This is what I promised I wanted to talk about when Ilya asked about reputation. So for the percent positive, we do the same thing. You know, we know that the mean is 99, well, it's almost 99.4. So we exclude anything below the mean, and then we include a dummy for between the mean and 100%, and then another dummy just for 100%. And what you see over here is that the coefficient on these two is actually negative. Now, if you would have interpreted this as a causal result, this would say when you buy from a higher percent positive seller, you're more likely not to come back to eBay. Okay, so when you kind of think of it that way, it makes absolutely no sense, because you would expect that positive, you know, a higher positive percentage is probably a better seller. Well, the problem is that the percent positive is observable to the seller, to the buyer, and buyers could select on that. So then what would happen? So Ilya has a almost 13-year-old daughter. Imagine that in 2 or 3 years, he decides that he wants to buy her a classic vintage Gibson Les Paul guitar. Okay? You could look for it on Amazon. You're not going to find it because you don't find classic vintage stuff there, so he has to come to eBay. Now imagine that Ilya doesn't buy on eBay because he doesn't trust eBay. But this is the only place he could find it, so he will come to eBay with two things in mind. One, he wants to minimize risk. Two, he doesn't like eBay, so he's not planning to come back. So what does he do to minimize risk? He looks for sellers that are 100% positive. Two, he doesn't come back. I get this negative correlation between selecting high positive and not coming back to eBay. So this is a selection story, not a causal interpretation, whereas these, because they cannot select on it, are causal. Now, of course, let me just quickly go over this. What we do over here, so remember that dynamic Bayesian tree, if I take it seriously, the implication should be the further I am down the tree, the less likely I should be affected by the quality of the transaction. So this is the distribution. Here we're showing you the estimated effect of EPP interacted with whether this is your first transaction, second, third, fourth, fifth. And the theory says this should be kind of downward sloping. Now, we see that for the first transaction, it's actually pretty low. And then it kind of jumps up, and then we have this nice monotonicity that the theory predicts. We really feel that we can't say much about the first transaction because, again, those people who come to eBay with the mindset of, I'm never going to come back, they will also not be that affected by the quality of the transaction because they have this very strong vindication. So if I kind of exclude the first purchase, we get this pattern that seems consistent with that idea of a dynamic Bayesian decision maker.
So,
Yeah.
So you do regression for every time step.
So we basically include a dummy for the interaction between your experience and the EPP, which is kind of like running separate regressions.
And the dummy, what values does this give?
So for this one, the dummy is 1 times the EPP of that transaction for people for whom this is their first purchase. To estimate this, it's the same dummy, but for people who are the second purchase, third, fourth, fifth.
See 5 minutes.
Yeah. So of course, you might wonder, well, what could we do with this? What could eBay do with this? And what we're arguing is that what the online platform could do is say, oh, well, we have something in the data that we could use to estimate seller quality. Well, if that's the case, then we could do two things. We could show it to the buyers and say, hey, here's another measure of seller quality. Maybe you want to use this. Well, the problem is if you kind of think of sellers harassing buyers, if now sellers understand that eBay is using this measure, sellers might just say, leave me feedback, leave me feedback, leave me feedback, and they're really going to harass people. So instead, maybe eBay could keep this secret, not tell people what they're doing, and at the end I'll say a word or two about this very disequilibrium-like thought, which is troublesome, and not use kind of the hard hand of Amazon, which is anybody who screws up, we're going to kick them off the marketplace, or the quite laissez-faire approach that eBay has always taken where anybody could sell on eBay, but look at a middle ground where if I've identified sellers that are not that good, let me demote them in the search. And that's the exact experiment that we did where, here if you go to eBay, you search for MacBook Air, you're going to get a list of sellers. Well, what if I now use EPP and decide, oh, the most relevant computer is this guy, but he doesn't have a high EPP. So maybe I'll move him to number 4, and then I'll elevate everybody else, okay, and vice versa. So we ran this experiment, and between December 14th and 2011 and January 2nd, 2012, where there was a 10% amount of traffic that came to eBay that they got a version of the search algorithm that promoted EPP, okay? But it didn't promote it by much because, Chris and I came and said, let's promote EPP, and then they have 20 other groups at eBay that these guys care about this, and those guys care about that. So, they're not going to elevate EPP dramatically. So you could see the distribution of the weighted EPP across the pages between treatment and control. So this is control, this is treatment. It was very mild. It was only about a 3 percentage point change in EPP. So that gives us a very small amount of variation. But even with that small amount of variation, we were able to get quite strong estimates. I'm going to quickly run through this. The two most interesting things are that, one, we get a strong effect of EPP in different specifications, and they're quite consistent with the reduced form estimates from the observational data. But the second thing that's interesting is, of course, because they did such a small change, if we look at the difference between conversion rates and treatment and control, it was a pretty flat zero. So this is the estimate on every day of the conversion rate, and you see a pretty flat zero. This is negative 0.1%, positive 0.1%. So they really didn't sacrifice any relevance. Now, of course, if they had more of an extreme shift of EPP, they may have sacrificed a little more relevance. So let me jump ahead to spend the last 3 minutes on follow-up work that I did with Dmitry Masterov and Uwe Meyer, who were at eBay. And this little note came out in EC15. So remember that thing about the messages, right? So should a buyer ever send a seller a message post the transaction? Well, here's an example of a message that surprised me that they exist, but you have some people like this, right? Hello and good morning. I'm glad to tell you that the 2 items arrived safely today. I'm very happy because I need it for a dinner party. Thanks a lot. Kind regards. Okay, this is really someone who has the time and energy to express themselves. On the other hand, I purchased 2 pairs of shorts from you at the same time, 1 pair gold red, which I have received, and 1 pair which I haven't received, so I should still be receiving a refund. Okay, this is not good news. And a buyer who experiences this clearly didn't experience a good transaction. So what we did then is, first of all, look at the information in the messages. This is a spline plot, and an internal metric that eBay has on customer satisfaction. And what you see over here is that transactions with no messages, only about 4% of them have some indication of dissatisfaction. So this could be a negative feedback. I didn't tell you about the DSRs, the detailed selling ratings. These are the stars that eBay use. That's another metric that they have, or even some kind of dispute. So that adds up to about 4%. If there is a neutral message, something where we didn't find any of those negative words, it jumps up to about 12% of transactions that actually have some indication of dissatisfaction. And if we identify the emails with the negative words, it jumps up to over 30%. So then what we could do is something very similar to what Chris and I did. And we could say, you know what? If Ramesh is a seller, and 2 out of every 100 transactions he gets a negative email, he has a 2% negative email rate. And if I'm a different seller and 5 out of every 100 transactions I get a negative email, I have a 5% negative email rate. So that means that I'm a worse seller with that metric. Here what we show is that negative metric, so a bigger number is a worse metric. This is kind of opposite to EPP. Here we have the probability of a poor experience indicator, and we see this very nice increase in that probability. And then we did exactly what Chris and I did with the reveal preference approach. We could replace EPP with this new measure and see how does that affect the exit rate. And that had a very strong impact, and here's what surprised us. It has as big an impact when included in the regressions independently as EPP. So suddenly I have 2 signals that seem to have a lot of disparate information, and 1 signal alone doesn't capture all this information. So I won't go into more details, but that's another issue in the here's another piece of data that this platform has that they could use to detect seller quality and use it to rank sellers. So to conclude, platforms will face a lot of challenges of asymmetric information because of the variety of sellers that sell on it. There are going to be externalities across these sellers and bias that limit the effectiveness of feedback. And what we think we contributed here is, clearly uncover these biases and show the reputational externalities, suggest this active screening using the search mechanism, and this email stuff. Now, what I think is really important here is to understand that these marketplaces do have an incentive to self-regulate. So they really do have an incentive to use this kind of engineering data science to pick up different measures of seller quality and use them in their ranking. But this is kind of going back to what I said, which is kind of blasphemy for economics. I really believe that there is an element of disequilibrium that needs to be played here. So, I know I spent half my life in Israel, and I know there are, at least a critical mass of Israelis if it's computer science and economics. And there's a whole area of electronic warfare. So I don't know how many of you know, there's electronic warfare and there's counter and counter, right? So you're always trying to stay one step ahead of the enemy. And I think there's going to be something similar that marketplaces need to think about here is how do we create mechanisms that we understand how we're doing the ranking? And a great example is Google Score, right? Google's quality score. Google never tells anyone how they're doing it, because if they tell people how they're doing it, they're worried that people are going to game the system and manipulate it. So I think the same thing is going to be true about quality ranking of sellers on these platforms. And that's the only way they will be able to get a better selection and a better ranking of sellers in order to give buyers a better experience. So that's it.
Why don't we see maybe one or two questions? David? Let's see if actually moderate.
So that was a lot of fun. Just in regard to the equilibrium question, and I guess an observation is the nice thing about using email messages is the message that's already being sent. So it's not as though you're looking for the buyer to send an explicit signal, so that seems helpful. I take your point about the disequilibrium, but do you think there's also kind of an interesting research question here in the equilibrium model that somehow talks to the design of a system that maybe deliberately uses randomization to make it difficult for the seller to make threats to try to change the signals provided by the buyer?
Yeah, that's an excellent question, because with randomization, we could kind of reintroduce equilibrium, right? Just kind of some mixed strategy on behalf of the platform that maybe, kind of like in Holmstrom and other models of signal jamming, right? So we're trying to jam the signal so people can't infer it. So that might be a way to proceed theoretically and see kind of what those kind of algorithms might yield. I think that's a sensible approach. Chris?
So presumably some buyers only leave positive feedback, but there are others who actually leave lots of negative feedback. Does your regression capture that I might want to take more seriously?
So the answer is no, and I think we even have a paragraph in the paper on that, and that is that, I should, as a platform, use machine learning and other algorithms to figure out that your feedback is more correlated with what I think is true seller quality, and now I'm going to overweight your feedback, and Eric only leaves positive, I'll just ignore him, right? So absolutely yes, and that goes back to that little point I made. This is an engineering problem as much as it's an economic design problem, and that's why I think there are a lot of interesting things that for an applied engineering approach are going to be interesting, and no AER referee is going to be interested in publishing something like that.
Their loss.
Yeah. Eric.
I had a question a little bit related to the talk that Susan was giving on the theme of A/B testing this morning. Do you have a sense, from a cost-benefit perspective, what it would cost? Because it was pretty surprising how many transactions have some flavor of negativity, if measured comprehensively. What would it cost eBay to lose all of the transactions that are somewhat negative? And then what would be the benefits to eBay from keeping all of the buyers who, when they have a negative transaction, leave? Did you get some sense of just cost benefit from the market?
So here's what we could do, and here's what we can't do. So what we could do is do a counterfactual of if eBay promotes this, EPP measure, for example. What will that do for shifting the distribution of exit along those? So that we could do quite accurately given the estimates from our regression. Because the experiment that we ran didn't have enough variation in EPP to cause a reduction in the conversion rate, we don't have a cost. So right now, the estimates we have say, the cost of doing this is 0. If we had a more aggressive change in the experiment that we could have seen a drop in the EPP, in the conversion rate, then we could have done a short run versus long run analysis exactly along these lines. Right now, we just don't have a short run cost. you're absolutely, so when we suggested running this experience, then the first thing people say, well, our algorithm is optimized, to do the right thing. Why do you want to muck around with it? So because it's optimized for conversion, not for customer lifetime value. And that goes exactly to the issues that Susan raised about short versus long run.
Why don't we stop there, actually? Thanks a lot, everyone. Take a